Hi, welcome. In this video, we will solve problem unique paths asked by companies like Amazon, Microsoft, LinkedIn, Apple, and many others. So now let's start solving problems on DP grids. Okay. So from here, we will solve problems on 2D arrays where we can apply DP concepts. Okay. And DP in grids in 2D arrays, it's bit more, I will say, easy, or I will say that this is specific, right? So when there is something specific, there is very less domain, you can solve problems very easily. Okay, so we can use DP in 2D arrays very easily. I will solve few problems with DP and you will get the complete understanding. Again, for this path also, you should be very clear with the recursion concepts and the backtracking concepts. Okay, so let's start solving this problem. There is a robot on an M cross N grid. So this is my M cross N grid. The robot is initially located at the top left corner, that is 0, 0. Here, this robot is located. The robot tries to move to the bottom right corner. So this is my bottom right corner. The robot can only move either down, that means this down, or the right at any point on time in time. Given the two integers m and n, return the number of possible unique paths that the robot can reach to the bottom right corner. Again, possible unique paths, number of possible unique paths. If you can see, this is sound exactly like number of ways. Remember, number of waves, we have solved problems like number of waves, staircase problem, right? So where when you have some stair, okay, in that problem, okay, maybe you were here and you need to reach to the bottom, right? So either you can take one step or two step or three step, right? So what are the number of possible ways to reach to the bottom of the stair? I guess this sounds similar to that problem. And yes, it is. And we will solve problem by the same technique. Okay. So let's understand first of all what is the problem. So here we have two directions, that is we can either move down or we can move to the right. Okay. So if I have two options only, either I can move down or right. So there is one way that I will first move on the right, then I will go down and I will reach to the bottom. Second way can be I can go down and then down and I will move to the right. Okay. And one more way, that is I will first do down, then right, and then down. Here also I will be reach the bottom of the matrix. Okay, bottom right. So there are a total three ways, and that's the answer is three to reach the bottom right. Okay. Now how we are going to solve? Exactly same as we have solved number of waves, right? We will figure out that from there, right, what are the possibilities we can, what are the steps we can go ahead, and then we will figure out eventually all the possible ways. Okay, let's see, let's take out one example. So let me create a good example, then you will get it. So let's check this example. Suppose you are here, okay, and again you need to reach to the bottom right. Okay, so what are the possible ways? Either you can take this path, okay, or you can take this path, or you can take this path, okay, or you can take this path. Okay, four possible ways. One, okay, and the other possible ways are either you can take this path, okay, or you can take this path. So total there are six possible ways. Six possible ways. Okay. So this is how we are going to solve this problem. Okay. And basically this is the answer and how we are going to solve this problem. Remember the same concept, right? Remember the same when we were having the staircase problem. Okay. Where when we were having a staircase problem, then we realized something. Okay. In that case, we realized something that suppose you are here, okay, and you need to reach to the top of it. You need to reach to the top of it. Okay. So either you can take a one step jump, or you can take a two step jump, or you can take a three step jump. Okay. Again, the same problem we can solve. We can start from zero and we can reach to the top, or we can start from top and we can reach to the zero, right? Okay. We can reach to the zero. Okay. and maybe we have solved from top to 0. You can choose any of the method. Okay, it's totally dependent to you. I generally feel this method's quite reasonable because of boundary conditions. I don't need to think or too much on the boundary conditions. So let's talk about that waves. When we were solving that problem, waves, okay, we figured out to find the ways of to find a 4 step, right? If there is a 4 steps, okay, to find how many possible ways, I need to find. I can take either 1 step, okay, then either or I can take a 2 step jump. Okay, I guess there were only two, or suppose there were three step jump. So if I am taking 1 step jump, now the same problem is converted into a waves of 3. If I am taking a 2 step jump, the same problem is converted into a waves of 2. If I am taking a 3 step jump, the same problem is converted into a waves of 1. The same thing, right? Okay, that's what recursion is, right? The same problem is converted into its smaller part, is into its smaller part. Only the state is getting changed, right? Waves of 4, it's now waves of 3. Okay, and what will be the answer of waves of 4? Basically, if I say my waves of 4 is nothing, it will be the waves of 3 plus waves of 2 plus waves of 1. That will be an answer. Okay. Similarly, what will be the waves of 3, right? Then we will again divide. Either I can take 1 step jump. Okay, let me put this a bit aside. Either I can take a 1 step jump, then a 2 step jump, or a 3 step jump. Then the same problem is converted into waves of 2. Then it will be converted into waves of 1. Then it will be converted into waves of 0. You have reached 0, right? You have reached 0. When you have reached 0, I will say that that is a possible one case, that is a one path. That means you can take 1 step and then you can take a 3 step. Yes, that is a path. Either you can take a 1 step, then 3 step, and you will reach to the 4 steps, right? So when you are hitting 0, that's a possible way. So here you will return 1. Okay, and in all the other cases, if you are hitting less than 0, right, then you will return -1, because that is not a path. -1, not -1, 0 basically, because that is not a path. Okay, so this is how we solved that problem. The exact same problem we can apply here. Okay, let me put it. Okay, let be in these notes. Okay, and let me put this example in here in the next slide. Okay, so we can apply the same thing here, right? You can start from here. Okay, you can check, right? You can either move in these two direction. Okay, now when you moved in these two direction, you are asking that what are the possible ways that you can reach to this bottom from here. What are the possible ways that you can reach to the bottom from here? You are asking this. Okay, then from this I have also again two paths. Okay, now you are asking from here what are the possible ways that you can visit here, what are the possible ways that you can visit here. Okay, then this also path will again constitute, right? And you will ask what are the possible ways that you can reach from here, what are the possible ways that you can reach from here. Now you can say like from here that is only one way. Okay, so what we will do, we can apply the same logic, exact same logic, that either we can, there are 2 steps, right? Either we down, okay, and or we can go right, right? So after moving to down, I can again ask what are the possible ways from that point, not from 0 comma 0, from that point to reach to the bottom, right? I can move to a right and I can ask what are the possible ways that I can move to that point. Okay, so we can solve this problem by any of the method. I am using the same that I have used here, from top to 0. Okay, so I will use the method from star to this man, right? So basically, I will start from m minus 1, comma n minus 1, this path, and I will reach to 0 comma 0. Okay, I will figure out this one. So let's see if this is the case. So in that way, you are allowed to move in this direction, because that's opposite, simply opposite, right? That is up and left. Okay, so now you have path that is up and left. Basically, I am starting from here and I am reaching to this one, right? So suppose I am standing at m minus 1 comma n minus 1 path, and I'm figuring out that I can either move in upward direction or I can move in left direction. Okay, that was, I guess, down, right? Yes, upward direction and left direction. So I'm asking here, right? From here, what are the possible paths? Okay, so from, suppose this is one point, and if I am constituting this point, let's put m and n values. So we have m cross n. So here m is 3 and n is 3. Okay. So if I put the values here, okay, that is m minus 1 comma n minus 1, that is 3 minus 1 2 comma 2, right? So if you are taking an upward direction, what will your value, right? That is 2 minus 1 1 comma 1 comma 2. If you are taking a left direction, that it will be 2 comma 1. Okay. Now you are asking again from 1 comma 2, what are the possible paths you can achieve? What are the possible paths? Again, you can either move in upward direction, either you can move in downward direction. So from here as well, right? Either I can move in up direction or in down left direction. Okay. So if I'm moving in upward direction, it will be 0 comma 2. If I'm moving in left direction, it will be 1 comma 1, right? So now you have these points. Okay. Now from here, you are asking again, what are the possible ways to reach 0 comma 0? So again, the ways are either you can move in this direction or you can move in this direction. Okay. So either you can move in upward direction, you put the arrows, or you can move in left direction. If you are moving upward direction, from here 0 comma 2, from here it will be, I guess, minus 1 comma 2, right? That you are going outside of it. You are going outside of it. So that's a false case. That's a false case basically. So this should return 0 because that is not a path. So this should return 0. So here for this value, I will return 0 to this function, right? 0. Now on the left case, okay, if I'm moving left from 0 comma 2, that will be 0 comma minus 0 comma 1. Okay. So 0 comma 1, that means I am, I guess, here, right? Here. That means in this case. Now from here, what are the possible paths? Again, I will draw, right? So suppose, right, there is one upward point and there is one left point. Okay. If I am going in upward direction, so it will be again minus 1 comma 1. And if I am going in left direction, it will be 0 comma 0, right? So if you are doing an upward direction from here, yes, you are getting out of it, so that is not a way. If you are moving here, right, then that's a way, right? So if I am achieving 0 comma 0, what I will do, yes, that is one path, right? That is one path. So I will return here 1. Okay, I will return here, that is one path. Now, what is the path? Let's see, right? You first move to 2 comma 2, then 1 comma 2, then 0 comma 2, then 0 comma 1, then 0 comma 1 to 0 comma 0. Let's quickly check it, right? So let me erase this all stuff. Okay, we are at 2 comma 2. From 2 comma 2 we are moving to 1 comma 2. That means we are moving here. From 1 comma 2 we are moving to 0 comma 2. That means here. Okay, from 0 comma 2 we are moving to 0 comma 1. That means here. From 0 comma 1 we are moving to 0 comma 0. That is from here. So yes, that is the path, right? That is the path. That is one way. So we will return one. Similarly, right? Similarly, we will do for each node, right? We will do for this one here, here, right? Here we can move, right? That is also one path possible, right? There will be different branches and we can solve this problem. Okay. So clear, right? We will having two paths, that is upward path and left path basically. So here you can see, right? Basically from 0 comma 1, okay, from 0 comma 1, if I say 0 comma 1, that means this path. Okay, can you tell me, you need to reach here, okay, and from here what are the possible way? What is the way? There is only one way from 0 comma 1 to 0 comma 0. Yes, that is only one way. So this answer should give me one way, and yes, it is returning me. How? See, you are at minus 1 comma 1, so this will be 0. You are at 0 comma 1, 1. So basically when you will when you will return this one, you will return 0 plus 1, that will be 1. So the answer will be 1 here. Okay. Now this will return 1. This I is getting 0, so it will be 0 plus 1. So it will be 1. This will return 1, and there will be some outputs from here. So 1 comma 2 will have some outputs from here. Okay. So we can apply the same thing, right? Now let's quickly do the pseudo code of it. Okay, how we are going to solve this problem. So now let's me write the pseudo code of this problem. So what will be the pseudo code? See, so you can call any function. Let's suppose paths. Okay, let me use yellow pen. Suppose paths, in paths, what will be the value you have? You have I comma j, right? Now here by this diagram, you can see whenever my base condition is, I am getting from here the base condition. What are the base conditions? Okay, from this dry run, I am getting the base conditions. That is, right, if my I is less than 0, okay, or j is less than 0, right, I should return -1. Sorry, 0, not -1. Okay, if I am reaching to I comma 0 and j equals to 0, that means that is a one way, right? So I will return 1 from it, right? So that will be my base condition. Okay, so I will write this base condition. If suppose my I is less than 0 or j is less than 0, I will return 0. Okay, I will write if suppose I is equals to 0, is equals to 0, and j is equals to 0, I will simply return 1. That is one possible way. Okay. Now after this, I will simply say there will be two possible ways that you can go, right? That is either in upward direction. What will be the upward direction? That you will call the same function paths with I plus 1 comma j. Sorry, I minus 1 comma j. I minus 1 comma j, that is an upward direction. Upward direction. See, your I pointer is here, j pointer is here, right? So upward direction I minus 1 comma j. There will be one downward, not downward. There will be one left direction. The left direction will be paths of I with j minus 1, right? So this was I minus 1 comma j, right? And this will be I comma j minus 1. Okay. So upward one and left one. Now after this we are getting two paths. Now what we need to do? We need to simply return the sum of it. So I will simply return their sum, that is up plus left will be the answer. Okay. And this is done, right? This is basically how we are going to solve this problem. Okay. So now you can simply call this problem, right? If I want to call this, I will simply call paths from m minus 1, okay, comma n minus 1. Once I will call it, I will get eventually the answer, right? I will call this function again and again, recursion will happen, and we will return this value. Okay. Now, if I am applying this, this is a simple, I am simply using recursion backtracking. Okay. If I am applying this, what will the time complexity of the problem? So see, when you are starting from here, you have two ways, right? Either you can move here and here, right? Similarly, from here, you are exploring two ways. From here, you are exploring two ways, right? That is getting out of the bound, but you are exploring two ways. So if I say in each grid cell, you are exploring two ways, two here, two here, two here, two here, two here. Everywhere you are exploring two ways, right? So the total time complexity will be 2 power of m cross n, because basically you are using m cross n times. Basically this 2, right? 2 is how many times? M cross n times, right? So basically this will be a 2 power of m cross n, time complexity. Okay. What about the space complexity? Okay. So see, the space complexity, if I talk about, are we taking any extra space? No, that there is only recursion space that we are using. Recursion stack memory. Okay. So if I say recursion stack space. So basically you are calling functions, right? And you can see in this path, right? In this path, when we achieved the result, right? I call this one and this one and this one and this one, right? So the longest path I can achieve, that is this one. Even if I'm going from here, that is also on the same path. So, right, how many function calls will be there, right? These function calls and then this function call. So complete column function call or row function call and then column length function calls, right? Basically you are achieving this, right? You can see, you can check our this path 2 comma 2, we move to here, then here, then here, then here, right? Even if I'm moving from here, from here, from here, because there are only two paths possible, up and left. So even if I'm starting from here, from here, from here, from here, so I will visit the total columns and total rows, right? So it will be big O of n plus big of n plus m, simple. If I say in these simple words, it will be big of n plus m, that is the space of recursion stack. Okay. Okay, that's a pseudocode that we have applied. Now we need to apply this DP, right? We need to optimize it. Okay, we need to think of optimization here, and we can optimize problem. Yes. Why we need to optimize? Okay, we always talk that we need to optimize. Why we are optimizing it? You can see here as well, right? We have done this function called 2 comma 2 to 1 comma 2. Okay, then we have 0 comma 2, then we have 1 comma 1. I guess here, do we have any function call? Let me explain you here. Okay, so suppose you are starting here, you are doing this function call, that was 1 comma 2 and 2 comma 1, right? Now from 1 comma 2, right, you again call two function calls, this and this. Okay, now from here you again do two function calls, right? This you get out of the bound, and here you are here. Now suppose when you will call from here, right, there will be again two function calls, right? Now from here you are also calling this one, right? This will also find out the result from 1 comma 1. So that means if I call from 1 comma 1 in upward direction, what will be one call? That is 0 comma 1, and one call will be that 1 comma 0, right? Yes, it will be one, that one will be 0 comma 1 this direction, and one will be 1 comma 0. So you can see, right, I have already solved this 0 comma 1. I know the answer of 0 comma 1 is this 1. That means from 0 comma 1 there is only one path possible, from one path possible, right? So why I can't directly give this answer to this 0 comma 1? Why this path is also, why this path is also exploring the same option, right? So to optimize these function calls, let each function call do not take again and again two function calls. So for this we are using DP. Okay, for this we are using DP, and we will use DP in grids. Okay, so now let's solve the same problem in DP grids. So basically what I will do, I will use an space of DP, right? So same space. Let's suppose I'm using this as a grid as my 2D DP. Okay, so this is my DP. Okay, and see, basically if you can see what I was doing my path function call, right? If I'm writing paths, okay, let's take path only, or paths. Okay, so I was having 2 comma 2. Okay, from 2 comma 2, okay, I was having two function calls that I can take. Okay, either I can move in upward direction, or either I can move in downward direction, and this will also create too many spaces. So let create a bit far. Okay, one is upward direction, one is left direction. Okay, in upward direction the paths will be upward direction 1 comma 2, right? From here we will get paths that will be, I guess, 2 comma 1, right? So let me put the indexes so that you will easily get 0 1 2 0 1. So from 2 comma 2, right, there will be one path that will be 2 comma 1, 2 comma 1. There will be one path that will be 1 comma 2. Now from here as well, you are exploring the two options, that is either in upward direction and the left direction. So I will explore paths now 0, 2 and paths of this will be 1, 1, right? So from here, these will be two paths. Now from here as well, I am exploring the upward and the leftward. Okay. What will be the paths will be either -1, 2 or paths that will be 0, 1. So now this will give me the result 0. So I am not exploring this one. There will be these two paths now, upward and downward, leftward. If I am exploring this path will give me 0, 0, sorry, -1, 0, upward path, -1, 1. Okay. Here I will get paths 0, 0. So that is the base condition I have meet. So I have simply written from here. So that's a base condition. It will return, this function call will return 0. This function call will return 1, right? So I will basically return 0 to it. I will return 1 to it. And basically I will add this sum, that will be 0 plus 1. So I will get 1. So it will return 1 to it. 1 to it. And this will return, this will give me 0 basically, and I will return 0. So here I will get the same answer, that is 0 plus 1. Okay. Now here I am getting 0 plus 1. What I will do, I will return this 0 plus 1 to here. That means I will return 1 and I will basically explore this path. Okay. So I will explore this path. Let's see. I will explore this path. So if I am exploring upward and the leftward, I hope I will make it. So P, let me put P because there is not too much space. In upward it will become 0, 1 and in leftward it will become 1, 0. From here there will be again two paths, up and left. So this will become -1, 1 and this will become 0, 0, right? Now we are applying DP, right? So we are at here 0, 1, right? We can directly take the value from this one, right? And we can say that here I will get, my answer will be 1. So we can directly return from 1. Okay. But we need to explore 1, 0. That is not there. So I will simply explore this 1, 0. 1, 0, if I am exploring, I will get two things. And let me check 1, 0 is not there. Yes, it is not there. So then upward and the leftward. So path one path will be 0, 0 and the leftward will be 1, -1. So I am hitting the base condition, right? This will return 1 to it, and this will return 0. So here I will get the answer 0 plus 1, that is 1. Okay. And I will give the answer 1. So here I will get the answer 2. Now see, here I am getting the answer 2. So I will put this answer 2 here, 1 plus 2. And from here I will give this answer 3. But there will be some answers from here as well. Okay. So see what I am doing. Okay. Now let me tell you in the DP, right? What I am doing, see my path functions taking two in values, right? Indexes, right? I comma J. So that's why I have created a DP of 2D array, right? I have created a DP of 2D array. I am exploring this, right? I am exploring this and I am saying what are the possible paths from here to reach 0, 0? What are the possible paths from here to reach 0, 0? Okay. So again, I will do call this one, right? Similarly, I will call this one, and right, I will call this one. So I will store these values in DP. How? See, I will basically come to here, right? And I will say to reach 0, 0, right? Right? How many, what are the possible paths? So I will get, there is only one path. So I will put here that there is only one path possible from 1, 0, 1. Similarly, I will figure out from here, what are the possible paths to reach 0, 0. That is only one, right? So I will put 1 here. Okay. Once I have put 1 here, I will say, right, what are the possible paths from here to reach this one, right? This will be a function call, a paths function call, remember. So I will say there is only one path possible here. Okay. So I will put 1 here. Similarly, I will put 1 here. Okay. Now let's talk about this one. From here, what are the possible paths? So there are one possible path, this one, and one possible path is this one, right? So I will basically add these two function calls, right? These are my two function calls. I will add these to my function calls and I will get 2 as an answer, right? Now what I will do, I will say what are the possible paths from here. So I will take this as an answer because this was my function call. This was to my function call, right? And the summation will be my answer. Remember, the summation will be my answer. Remember the summation. The summation will be my answer here. Up path and left, the summation will be my answer. So basically, 2 plus 1, it will be 3, right? From here, I am getting 2 here, 1 here. So I will get 3 here, right? And for this path, 3 plus 3, I will get 6. So basically, this will be my answer of my DP, right? DP of M minus 1, comma N minus 1. Right. So now let's quickly apply DP in our this pseudo code. Okay. And let me quickly copy this whole stuff and let me put it here. So if I'm applying DP here, so what are the things that I need to keep in mind? First of all, I need to pass DP in my function calls. Okay. And we'll pass DP here. I minus 1 comma j minus 1. This was j and I will pass dp. I will pass dp. I will pass dp, right? And I will create a dp of 2D array, right? So you can create a dp of 2D array. Okay. And you can initialize all the values by minus 1. Okay. In the starting. Now, see, if I is less than 0, j is less than 0, base condition will be going to be same, right? This base condition is going to be same. The only thing, one thing that you will add here, okay, I'm just putting it forward. The only one thing that you will add here, if dp of I comma j is not equals to minus 1, not equals to minus 1 because see, you have assigned 2D array with minus 1, right? This is basically you have assigned 2D array with all the values of minus 1. If it is not equals to minus 1, that means it is present with some value. So what I will do, I will simply say return dp of I comma j, not do any function calls. I will return dp of I comma j. Now I will explore this function calls, right? There will be a pass of I minus 1, right? J minus 1. And I will, before returning, I will basically store their answer in dp of I comma j. Okay, and I will return their answer. So I will return dp of I comma j. Okay. So basically this is how I'm going to solve. Up equals to left, you can also do it single go, right? That is also possible. You can write this function, then this function, you can do in the same run. So this is the pseudo code of applying after applying DP. DP in grids. So I'm applying DP here, right? And now what will be the time complexity? So see, right? Previously you were calling all these function, right? Here you were calling all these function. Now you won't do any extended further function calls. Basically, suppose you are getting an answer from here, right? You will directly put the answer. Okay. You will directly put the answer. Let me explain you. So here, right? Basically, you suppose stored this value to 3, right? So when you are calling this function, you are directly taking values from 3, right? So if there is a new, if it is filled with minus 1, then only you are exploring this cell. Otherwise, you are taking the values from the DP, right? So basically, you will explore all these cells in the worst case, right? Only, and if you are exploring all these cells, okay, the time complexity will be big O of m cross n only, right? No further function calls. And the space complexity, again, the recursion stack will be m plus n. Now, this is the recursion stack memory plus your DP memory. So that will be big O of m cross n. Okay. So you have decreased the time complexity, but you have increased the space complexity. Okay. So that is our solution by applying DP. Okay. Now can we solve this problem by tabulation? Yes. Now what is this tabulation? Okay. Okay. You can see, right, in many cases, many, like, if you I say, right, most of you will say it is the bottom up approach. Okay. But yes, bottom up approach, basically how you approach it, it's not from the, basically what we basically do in top down approach, right? This is my top down approach, right? I am at the top of this, right, cell, and I'm exploring the path. I'm going to zero, right? Bottom approach will start from zero, will exploring this path. So bottom means this is the bottom, right? That was the top, this is the bottom, right? From the bottom you have decided something. From the bottom you have decided something, that this what will be the values here, right? And you are filling it, and you are reaching to this, you are reaching to the top of it. Okay. So that is your bottom to top approach, bottom up approach. And how we are going to solve this bottom approach, let's quickly understand. So in bottom up approach, what we will do, we will use DP, right? Simply, right, we will use DP. And right, that is on the only space. Okay. And then we will do the simple iteration. And remember, each recursion problem can be solved by iteration. So let's see how we will do the tabulation. Right now, see, you need to reach here, right? This is your final point. You need to reach here. If I say, like, if suppose there are many, like all columns, right, here, suppose if there are more columns as well, what are the possible number of unique ways from these different rows, or you can say different rows, not different column, to reach this? Suppose you are at here, what will be the possible way? There is only one way. You are at here, what is the possible way? There is only one way. You are hit here, what is the possible way to reach here? One way. What is, you are at here, what is the possible way to reach here? One way. Similarly, you are at here, what is the possible way to reach here? One way. You are at here, what is the possible way to reach here? One way. You are at here, suppose, what is the possible way? One way, right? So all here, all the ways, right, in the same row, right? So zeroth row, if I talk about zeroth row and zeroth column, right, there is only one way to reach at 0 comma 0. If I talk about zeroth row, right, this entire row and entire column, there is only one way to reach here. That is simply straight, right? Either down or either up and left. Okay. Okay. So if there is only one way, what I will do, I will fill it with one, right? So basically, what I will do, I will fill it with one, right? One, right here also I will fill it. Okay, don't think, right, why you have filled it there is, you are at the here. So when, remember, when we are at zero, right, when we were at zero, that is also one way to stand here. Remember, in the number of ways we solved, when we are at the zero, that means we have reached here, that is also one way. Okay, so we are at here, that is also one way, one way, one way, right, from here. Now I need to decide from here, right? I need to decide from here. So basically what I am asking, I am asking dp of I comma j. Okay, I'm asking dp of I comma j. So basically there are two ways. Okay, remember, if you can remember the function calls, right? Remember the function calls, that I am deciding by these two terms. I am deciding by these two. If I am taking up, if I am taking left. So what I will do, I will check if dp of I minus 1 is defined, right? So if it is defined, so my answer will be I minus 1 comma j, okay, plus dp of I and j minus 1. Okay. So basically dp of I comma j will be dp of I minus 1 comma j, dp of I j minus 1. So basically if I remove this thing and if I put 1, right? So 1 plus 1, okay, the answer will be 2 here, right? Now what will the point here? 2 plus 1, that will be 3. Now here 2 plus 1, that will be 3, right? For this one, 3 plus 3, that will be 6. And I will return dp of m minus 1 n minus 1. That will be my answer, right? So basically I can simply run a loop. I can fill all the rows. I can fill all the columns. Maybe not all the rows, all the columns, single row and single column. And then I can start loop from here, right? And I will fill all these boxes basically by using this condition, right? This is basically your upward direction and this is basically your left direction. Okay, up and left. Okay. So now let's see what will the code of it. Let's quickly see. So let me write it here as only, right? So the pseudo code, because it will be very short. Okay. The pseudo code will be basically you will declare a DP of a 2D array. Okay. Okay. And you can assign again with all the values with minus. Now there will be first for loop that will start from 0 to n. Okay. And in this loop, what you will do, you will simply assign DP. Okay. And this is m rows. So let's do m. So basically I am doing this for rows. Okay. This is for the 0th row, or basically 0th column, right? 0th column. I am doing this for this one, right? This one. So 0 to m, what I will say? I will say DP of I and DP of 0 will equals to 1. Done, right? Now I will do for 0th row. How I will do it? See, I equals to 0. I will go till n and I will say DP of 0 comma I equals to 1. Done. I have done all these things. I have done all these things. When these two are done, okay, once these two are done, okay, I am not getting any space here. So let's move the code to the next window. So once I have got this one, me shrink it. Once I have get this one, what I will do? Now I will run one more for loop that will start from 1 and it will go till m columns. Okay. Then one again for loop that will start from 1 and it will go till n columns. Okay. And now what I am doing? I am simply doing that upward and leftward. Okay. So I will say my DP of I comma j will be equals to DP of I minus 1 comma j and plus DP of I with j minus 1. Done. Once this is done, right, I have done this for loop its end. Here I will return DP of that is your last value, that is m minus 1 and n minus 1. Okay. So yes, this will be the pseudo code of your tabulation method. What will the time complexity here? Okay. So basically you are running one loop. This will run for m times. This is running for n times and this will run for m cross n time. Basically you are starting from here m minus 1 into n minus 1. Okay. So if I say the time complexity, because you are visiting each cell, okay, so it will be big of m cross n. Okay. But what about the space complexity? The space complexity will be now only the DP, that is big of m cross n, and not the recursion space, right? So we have decreased the space complexity and that's an optimization method. Okay. So this is the time and space complexity, but can we further optimize this, right? We are able to achieve the time complexity of big of m cross n and space complexity of big of m cross n. Can we further optimization? Can we do the space optimization? And yes, if we will try to understand this tabulation, okay, we can do again further optimization. So basically, if I am finding this 2, right, how I am able to find this? By the help of these two cells, right, by this path or this path. Let's quickly check the code of our tabulation. DP of ij is dependent of DP of I minus 1 j and DP of ij minus 1. I am taking an addition of this one, right? So 2 is basically 1 plus 1, 6 is basically 3 plus 3, and 3 is basically 2 plus 1, right? So you can see at any cell, at a time, at any cell is dependent of its previous row and previous column. Yes. So whenever there is a previous, right, whenever there is a previous row, okay, if we have a previous row, why I'm putting a bracket, if we have a previous row and a previous column, we can optimize it. We can do an space optimization. So I will say yes, we can do space optimization. Okay. So how we will do the space optimization? You can see for this cell, the only requirement is previous row and the previous column, right? And even in the previous column, I want this value only. And in the previous row, I want this value only, the top of the value and the last of the value, the like left value. Similarly for this one, top value and the last value. So instead of this, if I take an array, simple array of m columns, okay, basically this is m rows and n columns, so n columns. So if I take the array and a row and I will fill it. So let's see. Okay, there are only 3 elements, so I will also put 3 only. So we have 0, 1 and 2, and that's it. Okay, how I will do it? Okay, what I will do, I will first put, right, like my base case, you can see like my base case here, I will put 1 1 1 because, right, to reach 0 there is only one way, so I will put 1 1 1 in each of the value. Now what I will do, I will let's first solve for this row. Okay, I will solve by row. Okay, so let's solve for this row. Okay, how I will get it achieved? So basically if I solve for this row, that is my answer only, right? This is my answer. What I will call, this is dp. So that programming, let's say dp2. Okay, so that is the same row, right? No need to do any change, right? That is the same row. Now let's come to the next one and start filling the elements from here. Okay, why here? Because that is one only, because that is already filled. This one is already filled, right? So I will fill the elements from here. Okay, so what I will do, I want to fill this space like 2 and 3, 2 and 3. So what I will do, I will say that the value here will be dependent of this one and this one. But what will be the above? That is this one only, like the same element will be at the above because I have already filled with 1, right? And this is 1 already. So what I will say, my dp2 of, if that is a pointer of j, suppose my dp2 of j will be d, dp2 of j plus dp2 of j minus 1. Okay, so I am adding this one and this one, right? So if I'm adding the same, right, 1 and 1, I will get 2 as an answer. What I will do, I will move forward. I will move forward and I will do the same. dp2 of j will be dp2 of j plus dp2 of j minus 1. So 2 plus 1, that will be 3. Yes. So I have filled this row, I have filled this row, right? I have completed this row, right? Now what I will do, I will do for this row. Okay. Again, what I will do, I will start from here. I will start from this j. Okay. And I will say, okay, what was the value? 2 and 3, remember. Okay. I will say that dp2 of j will be dp2 of j plus dp2 of j minus 1. So 2 plus 1, that will be 3. So I will say 3. Okay. Now I will move next to this one. I will say dp2 of j will be dp2 of j plus j minus 1. So 3 plus 3 will be 6. So you can see I'm using simply one array. I'm using simply one array to fill all the elements, right? So previously my one array was this copy of this one, right? How I was filling? I was filling with 1, this one taking with this as an 1, so become 2, right? Then I was filling 2 and 1. I got 3, right? So that was 2, 3. So I will fill by rows, right? So the loop will go till m cross n, but I will use single array only, single array. So space complexity will be reduced to big of n only. So now let's check the pseudocode of space optimization. Okay, so this is the space optimization. Okay, what I will do, I will create one dp of basically of size n. So you can say new array of size n, that's a pseudocode, remember. It's a pseudo code. Okay, I will say dp of new array of size n only, and I will fill with 1. Remember, I will fill with the 1 base case. Okay. Then I will start a loop that will start from 1 to m rows, and I will start a loop that will start from 1 to n columns. Okay. And now inside this, what I will do? Okay, I will say the same thing. dp of j will be dp of j plus plus not equals to plus dp of j minus 1. Okay, and that's it. In the last, what I will do, I will return dp of j minus 1, the last element. Okay, that will be my answer. So this will be my pseudo code. Okay, not a good line. This will be my pseudo code. This part will be my pseudo code. And now if we check, we have reduced the space. Now the time complexity is again big O of n cross m. Time complexity is big O of n cross m because of nested loops, and space complexity is big O of n only. So that's a space optimization. Yes. So you have seen, right, three approaches, right, to solve this problem: by using one DP, then by using tabulation, bottom up approach, and then by using space optimization. Okay. And yes, we are going to implement all these three. So in the next video, I will implement all the three approaches in the code editor. Okay. And then I guess there is no need of dry run, because here I have shown you how basically this code is working. The same thing, whatever the code we have created here, we have also created by the doing the dry run only. So that, I guess, self-explanatory. Okay. But if I will say, I will check if it is required, I will show the dry run. Otherwise, I will put the code implementation video. Okay. So go check it out, the code implementation video. I have applied all the three approaches in the code implementation part. Okay, go ahead, you can check it. And that's all for this video. See you in the next problem.